Hey friends, today we're talking about scale. Okay, so let's talk about drawings and models. These are used to represent objects that are too large or too small to be drawn and were built in actual size. So for example, if I were going to New York City, I would see the Statue of Liberty. But what I could take home wouldn't be a life-size version of the Statue of Liberty. Instead, it would be like a model of the Statue of Liberty, scaled down, okay? Listen to that word, scaled down. So it's an image or a representation of the actual size, but not the actual representation. Okay, so scale is the ratio that compares the measurements. So for example, in history, we have maps, right? Like this one. If we're looking from Hagerstown to Annapolis, and I use this scale right here, 1 centimeter, or every centimeter, equals 24 miles. And if I measure this, it's about 4 centimeters from Hagerstown to Annapolis. So if 1 centimeter is 24 miles, I want to know what 4 centimeters would be. Well, 1 times d is 1d, or just d, and 24 times 4 is 96. So d equals 96. There's nothing to divide by because it was multiplied by 1. So the distance between the two cities is about 96. If we used repeated addition for every 1 centimeter, so 1 centimeter, each of these would be 24. So 24 plus 24 plus 24, or 24 times 4, 96. Okay, let's look at another example. On the map below, the distance from Clarksville to Little Rock is 4 centimeters. What would the actual distance be? Okay, so we know that their distance is 4 centimeters apart. Okay? And we know for every 1 centimeter, it's 20 miles. Okay, Miss P, how do you know which one goes on top? It doesn't matter. I could do the 20 on top and the 1 on the bottom, and the 4 on the bottom, and my unknown on the top. Okay, so either way, we're going to see what they equal when we use cross products. So 4 times 20, 4 times 20, see that I'm multiplying the same thing? That's why it doesn't really change. So let's call this unknown x. So if I take 4 times 20, it's 80, and 80 equals x, which means that they would be 80 miles apart. So let's write that. From Clarksville to Little Rock, it's 80 miles apart. And I'm going to bubble that in because that is my answer. Excuse me. Okay, let's look at another one. A graphic artist is creating an advertisement for this cell phone. If she uses a scale of 5 inches for every 1 inch, what is the length of the cell phone on the advertisement? So the advertisement is 5 inches and the actual is 1 inch. Okay, so it's getting bigger, right? So if we have 4 inches as the actual, what is the advertisement? So 5 times 4 is 20, and 1 times A is A, so 20 equals A. So the length of the cell phone is 20 inches long. Okay, try this one on your own. A scooter is 3.5 feet long. Find the length of the scale model if the scale is 1 inch for every 3/4 feet. Okay, go ahead and set up your proportion. Pause the video. Take a second and try it yourself, okay? And then I'll be back in just a second to show you the answer. Okay, so here's how I would set it up. I would put, for every 1 inch, it's 3/4 feet. So if I wanted to figure out how many it would be for 3.5 feet, that would also go on the bottom. Remember, they need to stay in proportion with one another. So this is the scooter's length in feet, and this is it in the scale in feet. So I'm going to cross products. Okay, so I have 3/4 x equaling 3.5. Okay, so I'm going to divide 3.5 by 3/4. And when I do that, I get x equals 4.6 repeating, which we know is 4 2/3. So if you put this in on your calculator, you can take and put it in the decimal form, or you can use the fractions buttons. Okay, but make sure that you change this back to a fraction. Since we're working in fractions, don't leave it as a decimal. Okay, so, and we make sure that we put inches. Okay, let's try this one. An artist is painting a large mural of the flowers on the side of the school. If she uses a scale of 4 inches for every 1 inch, how large will the mural painting be if the rose bloom's actual height is 6 1/4 inches. Okay, so the painter's making it bigger. So her mural is going to be 4 inches for every one of the actual. Okay, so when I look at this, if the actual height is 6 1/4 inch, then I want to know what the mural will be. So 4 times 6 1/4, or 6.25, is 25, and 1 times my x, my unknown, is just x. So x equals 25 inches. Another example, a floor plan for a home is shown at the left, where 1/2 inch represents 3 feet of the actual home. What is the actual area of bedroom 1? Okay, if we look here, the length of bedroom 1 is 1.5 inch for every 3 feet. Okay, so the floor plan is 4 inches for the unknown. Okay, these are our actuals. This is the floor plan. So if we multiply 1/2 times W, and 3 times 4, we get 12. Then we divide by 1/2, or we can flip and multiply, right? Which would be like multiplying by 2, so W equals 24. The width of the bedroom, okay, we're looking at the bedroom, is for every 1/2, it's 3 feet. So if the actual is 1 inch on the floor plan, then we have 1 times 3, and then we can flip and multiply, remember? So times 2, so x is 6. So the dimensions are going to be, the width is 24, and the length is 24, and the width is 6. So how do we find the area? Area is length times width, okay? Make sure you have this formula written down. That's what area is of any rectangle. And since this is a rectangle, we multiply the length times the width. So 24 times 6, and when we do that, the area is 144 feet, and they're little squares, right? It's squared feet. Okay, so make sure that you have the correct label. Okay, so you try to figure out bedroom 3 for me. Go ahead and try the problem. I'll be back in just a second to show you the answers. Okay, so here we go. So we have, for every 1/2 inch, it's 3 feet. We're looking at this bedroom here. It's a 3 by 1. Okay, so if we have 3 inches, we want to know what would be the length. Okay, so right here, 3 times 3 is 9, and 1/2 of x, so we're multiplying by 2 to get rid of the 1/2, so x equals 18. So this would be 18 feet right here. Okay, down here we have 1, so 1/2 time over 3 equals 1 over x. So when we multiply, we get 3 equals 1/2 x, multiply by 2, x equals 6. So this one would be 6 feet. So it's an 18 by 6 foot, and the area is the length times the width, so 18 times 6 gives us 108. So the area here would be 108 feet squared. Make sure you have that squared. All right, what about the hallway? Okay, if we look here at the hallway, this is a 1/2 inch, and together the hallway extends the length of the bathroom in the bedroom 1, or 2 plus 4, which is 6. So let's look at this. If every 1/2 inch equals 3 feet, and we have a 1/2 inch, then this right here is 3 feet. Okay, if we have this one, 1/2 inch equals 3 feet, and what would 6 feet be, or excuse me, 6 inches be? I should put that on top, not on the bottom. 6 inches be, we would take 3 times 6, which is 18, and set that equal to 1/2 x, multiply by 2, and we get 18 times 2 is 36. So we have a 36 by 3 foot room, because we're doing the length times the width. Multiply that 36 by 3, and this area is 108 square feet as well. Okay, and that's all I have for you. I'll see you next time.